evaluate the integral of x to the 5th over 1 plus x to the 12th dx. Now, you might be thinking about making a substitution here, and that is the right strategy, but it might not be the substitution that immediately comes to mind. We've seen some similar problems where we let u equal the denominator, and that's going to actually cause us a problem. If we let u be 1 plus x to the 12th, then du is 12x to the 11 dx, and we don't have an x to the 11th in the numerator. So we kind of end up with an issue. So that's not going to be the substitution we are going to make. But there is a nice substitution we can make that's going to make this look very similar to something we've seen before. And I'm wondering if you might be able to figure it out yourself. Pause the video for a minute and see if you can figure out a better substitution for this situation. All right, the substitution we're going to make here is we're going to let u be x to the 6th. Now, the reason this is going to help us is because we can take the denominator and write this as 1 plus x to the 6th squared, because x to the 12th is just x to the 6th squared. And if we make this substitution where u equals x to the 6th, the denominator is going to be 1 plus u squared, which we've seen with integrals before. We know that that is part of the integral that gives us arctangent. And if we look at our u equals x to the 6th and differentiate, that gives us du equals 6x to the 5th dx. And you can see that this x to the 5th dx is what's left over outside of that denominator. I'm just going to divide both sides by 6 really quick. And once we've done that, we can replace the x to the 5th dx with 1/6 du. We'll put a 1 in that numerator. And once we've done that, we can integrate this. We know the integral of 1 over 1 plus u squared du is inverse tangent of u. And then we've got our constant of integration on the outside. And we just have to replace u with x to the 6th. So this is going to be 1/6 inverse tangent of x to the 6th plus a constant. You could also write this as inverse tangent x to the 6th over 6th plus a constant. I think it looks a little bit nicer that way, but both of those have the same meaning in the end. So there we go. And this is just an example of how you might try one substitution and find that it doesn't work. Now, that might mean that substitution isn't the right pathway, or it might mean that you need to be creative and use another substitution. And the only way you're going to get really good at this is if you do a lot of problems and get a lot of practice and build up your intuition of what to try in each situation.